Welcome to The Explainer. Today, we're diving into a really cool corner of artificial intelligence that's all about learning from experience. It's called reinforcement learning, and it's how we get machines to master these incredibly complex tasks, pretty much all on their own.
So, let's just start with a puzzle. Think about this. How does a computer learn to win a game like chess or Go? I'm not talking about memorizing a huge database of moves from grandmasters. I mean starting from absolute zero and just playing. How does it go from knowing literally nothing to developing superhuman skill just from experience?
And you know what? The core idea is surprisingly simple because it's exactly how we all start learning. Think of a baby just playing around, figuring stuff out. There's no teacher with a lesson plan. There's just interacting with the world, a constant feedback loop of cause and effect. That's really the big idea here.
Okay, so here's the official definition. Reinforcement learning, or RL, is all about learning how to map situations to actions to get the highest possible score in the long run. Our learner, what we call the agent, is just trying to maximize a reward. Win the game, you get a +1. Lose, you get a 0. It's really just all about chasing that reward.
And this is absolutely crucial. The agent is never told which actions to take. It's not like other kinds of machine learning where you feed it a bunch of labeled examples. Nope. Here, the agent has to discover for itself which actions lead to the best rewards. It's got to explore and figure things out on its own.
This whole process really stands on two big pillars. First, there's trial and error. The agent is literally just trying stuff to see what happens. And second, and this one is so important, is the idea of a delayed reward. See, the best action right now might not seem great, but it could be the move that sets you up for a win way down the line. The agent has to learn to think ahead.
To really get what makes RL so special, it helps to see where it fits into the whole machine learning universe. It's one of three main ways we get computers to learn, and each one is pretty different.
So, most of the machine learning you probably hear about falls into two camps, right? You've got supervised learning, which is kind of like studying with flashcards. You have the question and the right answer. Then you have unsupervised learning, which is like being given a giant pile of photos and told to find patterns. But reinforcement learning, well, it's a totally different beast. It's this third way of doing things where an agent learns just by doing, trying to get the best possible score over time.
All right, so that's the theory. But how does this actually work in practice? Let's take a super simple game that we all know, tic-tac-toe, and see how the learning really happens. So imagine this. We set up a giant table, and in this table is an entry for every single possible tic-tac-toe board you could ever have. Each spot on that table holds a number. That's the agent's best guess of its chances of winning from that position. But at the very beginning, it has no clue. So it just assumes every position gives it a 50-50 shot of winning. Then the agent just plays, over and over and over. When it's its turn, it looks at all the possible moves and picks the one that leads to the board it thinks has the highest value. It makes its move, sees what happens, but it doesn't get a reward till the very end of the game. Now, here's the magic. After a game is over, it looks back at the moves it made, and it nudges the value of the previous board position to be just a little bit closer to the value of the one it moved to. It's literally learning from the difference between its own guesses over time. That's the secret sauce that helps it get smarter.
And you know what's wild? This method isn't some brand new cutting-edge idea. It's basically a computer version of a psychological principle from over 100 years ago called the law of effect. All it says is that actions that lead to good outcomes are more likely to be repeated. The agent is just learning to prefer moves that lead to places it has learned are good.
Okay, but this whole learning process creates this huge, constant dilemma for the agent. At every single turn, it has to make a really tough choice. This is what's known as the exploration-exploitation dilemma. On one hand, the agent can exploit its current knowledge and make the move it already thinks is the best. On the other hand, it could explore by trying something totally new, maybe even a move that looks bad, just to see what happens. Exploiting is safe, but you might miss out on a brilliant strategy. Exploring is risky, but it's the only way to find those game-changing new ideas. Balancing these two is one of the toughest parts of RL.
So, this idea of a giant value table is perfect for tic-tac-toe, but what happens when the game gets way more complicated?
In tic-tac-toe, you're looking at around 5,500 unique board setups. That's a number a computer can totally handle. It can build that table and, if it plays enough games, learn the perfect move from every single one of those positions. But now, look at a game like backgammon. The number of possible states is 10 to the power of 20. That's a 1 with 20 zeros after it. It's a number so huge, it's more than the estimated grains of sand on every beach on our planet.
You simply can't build a table for that. It's not even possible to see every position, let alone memorize a value for it.
So what's the solution? Well, you stop memorizing and you start generalizing. Instead of learning the value of every single specific board, the agent learns to recognize the features of a good position. It learns patterns, and that's what lets it make smart moves in situations it's never seen before. It's exactly how a famous program called TD Gammon learned to play backgammon at a world champion level.
Okay, let's zoom out from the games for a second and look at the big picture. What is the ultimate goal here? What is reinforcement learning really trying to do?
When you really boil it down, RL is a framework for building these complete, interactive, goal-seeking agents. These are systems that can learn to pull off complex goals all on their own in messy, uncertain environments just by interacting with them. They learn how to plan, how to think about consequences down the road, and how to make tough decisions. This is the stuff that's powering everything from game AIs to the next generation of robots.
And all of this leaves us with one final, fascinating thought. As these agents get more and more powerful, they won't just be learning to master the tasks we give them. They'll start discovering strategies and solutions that we never could have imagined. So the most interesting question becomes, what are they going to discover on their own?